Okay, welcome back for the course EV and RE, Electric Vehicle and Renewable Energy. In the first half, what we have done that we have covered almost all aspects of the electric vehicle, including the cost, technology, various parts, subsystems, how to calculate for the energy, the power, and all the things we have discussed during the first half, including what type of cells we should use for electric vehicle application. In the second part, we have talked a lot about renewable energy, especially generation, policies, cost, sources. This is going to be the last chapter for this course, and this course will deal with storage options for the energy. If we go towards renewable energy, if we have to improve the renewable energy consumption, then there has to be a layer there must be a layer to be added in the system or in the architecture, and that is nothing but energy storage. Now, what type of energy storage, what options we have, those things we will discuss today. The reason behind this is the renewable energies are not controllable, it is intermittent, and when it is there, it cannot follow your load curve always. So, you should have some options where you can, whenever there is excess, you can store it, and whenever it is needed, you can take it from that place. And in that case, the uses of the renewable energy can be improved much significantly. What we have today is around 8 to 15%, that is a maximum capacity, that is a maximum renewable energy we are using. However, installed capacity is more than 25%. Again, the reason is mostly we do not have a layer which can store the energy and give us whenever we require. Now, when we talk about options for energy storage, it could be in various forms, very short duration, medium duration, and long duration. So, we will talk most of the things here, not much mathematics. We wanted to know more here in this chapter, that what are the options available for storing the energy. So, let us move. What is the energy storage system? The energy storage system, in short we also say ESS, energy storage system. It is referred to a device or mechanism by which we convert energy in a form which can be stored. So, not only conversion of energy in a form which can be stored, also it can give the energy in the form we require whenever there is a need. An energy storage system is something, a device or a mechanism or equipment or a facility which stores energy and gives back in the form when we need in that particular form. What you see here is a cell. The smallest which everybody is familiar with is a cell, AA, which we use from the long time in our torch when there was a lot of power cuts. It is nothing but it is energy storage device. Calculators, there is a small cells in the back of the calculator, that is nothing but a small energy storage device. In your remote, in your TV remote, you put 2 cells or 1 cell depending upon the remote, that is nothing but an energy storage device. UPS, when there used to be a lot of power failure, almost every house has a system known as UPS, uninterrupted power supply. In a desktop, the computer, you always put a UPS. What it has? It has a battery which stores energy when the power is available, and when power goes, it gives back the energy in the form which is required for the computer. In the house, when we say inverter, UPS inverter, when there is a power, it keeps storing the energy into the battery. When power goes, at that time it gives back the energy in the form of electrical energy, so that we can still run our lights, fans, etc. In the large form, what we are talking here is in a watt hour thing, maybe 5 watt hour, 10 watt hour, 100 watt hour energy storage. But that would not work if we have a cluster of homes. Let's suppose a small town. When power goes in a town, all the houses there is no power in any of the house. If there is a grid failure somewhere nearby Chennai, the whole Chennai will be black. Reason is there is no power anywhere. In such cases, when we have to, and the requirement of power is quite large, it could go in megawatt or sometime in gigawatt. What we need to do in such cases? We need to have a storage of that order, megawatt hour, gigawatt hour, which can supply the energy for that time, for hour or 2 or 3, till the time grid comes back. Now, in the case of renewable energy, it becomes very important, because sometimes we have a lot of energy available, but we cannot utilize. That means capacity is available. The good thing about renewable energy is that if you are not using, it won't be generated. Like if you take solar panel, if you have an installed capacity of 10 megawatt and you are utilizing only 4 megawatt, that means only that much power would be generated by the solar panel. Similar way, wind. You may have multiple windmills, but and you may, let's suppose you have a 1 gigawatt power capacity windmill, but your power requirement is only 200 megawatt. Will it generate 1 gigawatt or 200 megawatt only? It will generate only 200 megawatt. So basically, you are not utilizing the system or capacity to its full extent. But let's suppose if I have a storage, what would be the storage requirement? The storage requirement will be in the order of gigawatt. And how to achieve those type of storage, that also we will discuss in that. So right side picture, what you see here is a battery storage, battery energy storage, and each of this would be close to 1 megawatt. Each of this container would be close to 1 megawatt. So several of this container would be placed with that to achieve the gigawatt storage capacity. Why there is a need of energy storage? What you see here in the picture, that we have multiple battery racks, what I have shown in earlier picture, like that. So we have multiple battery packs. Generally these battery packs are at high voltage, maybe 700, 750, 800 volts, 1100 volts. The reason behind is that the current requirements comes down as soon as you keep on increasing the voltage. And then you have AC-DC converter, DC-AC, bidirectional converters. Then you have a communications lines, when it need to be switched on, when it need to be switched off, and those arrangements means control. Then you have a power conditioning system, power conversion as well as conditioning system, and then that power goes to grid or your home or anywhere else. So this whole together up to this, we say it's a energy storage system, because as the definition what we said, it can store in usable form and gives back the energy in usable form. So battery simply cannot give you the energy in your usable form. So what we require? A power conversion system. We also say it's a power conditioning system. And then also you need to have a control, that when it need to be switched on, when it need to be switched off, what should be the storage rate, means capacity rate, at what rate you should discharge it. All those things you need to take care, and that's we say power conditioning. And then next comes energy management system. So what it does basically, energy storage, what it does? It increases the reliability and flexibility of renewable energy network or renewable energy generator. It could be solar, it could be wind. When I say reliability and flexibility, at 12 o'clock or 2 o'clock mid-noon, between 12 to 2, you may have the maximum solar power, and during that time you must need to utilize it, but generally your utilization capacity would not be that much. So what you need to do? You need to store. As soon as you go in the evening, winds pick up, solar goes down, so you still have energy, but at midnight you may still have sufficient energy to work out. But what happens to midnight? Now you don't have solar, now you don't have energy. So that time energy storage should provide the energy. Now this is as a if there is a clear sky. Now what happens? Suddenly in the mid noon clouds appear in the sky. The solar power what you had available was 1000 watt per meter square approximately, has come down drastically immediately within fraction of second or within a second or within a minute to 400 watt per meter square. Now your whole capacity has come down. Generation capacity itself has come down. Now what you will do in that time? So if you have stored energy, you will match the demand in that case from that storage. So that's why it's, and that's not true with the thermal power plant or such type of gas powered power plant. It can pick up the load or demand in a minute mostly to match the demand. It can ramp up the energy generation in the minutes. That is not possible with the renewable. So that's why the energy storage is required, and it provides you basic parameter for energy is reliability and its flexibility, and that's a very important thing. Uninterrupted power supply. If my generation capacity has become low suddenly, in such cases it should give you extra power, not like okay this area need not have power, this area need not to have power. It can still provide the power everywhere from the energy storage. Transmission and distribution. Now several times what happens, a thermal power plant which is running in Korba in UP, MP, might be now in Chhattisgarh, that is producing 1000 megawatt, but at that place the utilization is only 200 megawatt. In Chennai, another power plant is generating only 200 megawatt, but the utilization is 800 megawatt. So there we have surplus, here we have a deficit. How do we match it? So we have a grid system. So we can transmit power from that place to this place. Similar way, Tamil Nadu has very high, much higher potential of solar energy. It can generate a lot here, but that may not be possible somewhere in Jammu and Kashmir. How do we transfer from this to that place? Again through grid. Now, if there is a possibility of localized renewable energy sources, because in Jammu and Kashmir lot of hydroelectric power plant can be set up. I will not talk about advantage and disadvantage of that, but yes, there is a potential. And something happen in between that, the energy which is supposed to be transferred from Tamil Nadu to that place, and if I have a local storage nearby, so even an interruption in the grid will not make the whole things blackened or blacked out situation, because the local energy storage would be able to provide the energy for sufficient times, maybe hour, maybe 2 hours, by the time the system or the grid system can be rectified in between. So that's what is transmission and distribution system support. Bulk power management. What I mean to say bulk power management, suddenly one plant goes off, what you will have, what option you have? Large storage that can give you the immediate energy. By the time you switch on the second plant, it can give you the energy till that time. or suddenly it's raining, suddenly it start raining. Now you don't have any renewable energy, especially on solar side. So your energy generation dips. So at that time energy storage can provide you sufficient energy by the time the sky becomes clear. The another important factor of energy storage or need for energy storage is deliver right amount of power at right quantity, and that's very important because it's whole day the renewable energy keeps on fluctuating, but your demand also keeps on fluctuating. You don't know it's in the same direction or in opposite direction. In such cases, energy storage gives you an option. Okay, how much they need only you give, and the right quality. If it is at 50 hertz AC, then it has to be at 50 hertz. It won't allow to go to 55 hertz or 45 hertz. It keep on supplying extra energy at the 50 hertz because of its storage capacity. During the peak hours, now you can always use this stored energy during the peak hours because you don't have to worry about the peak conditions. What you have to worry about is average out. So you are basically averaging out. So if you have something like this, your demand is like this way. So what you will try to do this, that you try to average it out, and this averaging out can be done using energy storage. You have also option of lower grid rejection losses, and that to accommodate all projected installation of future, present or immediate future, solar and wind, other sources also. How do we take what type of energy storage we should look on? So the power output versus energy consumption, that's a very nice graph, and the source is Korea Battery Industry Association 2017. So if you require a energy storage for few seconds and the capacity up to 1 megawatt, a super capacitor becomes a good option because it can discharge. The discharge rate is very high, 10C, 20C, 30C, and the charge rate is also very high. Similar way, in between seconds to minute and up to certain megawatt, you can always put those things in the parallel, which will give you a very high capacity. Flywheels comes a very good option. Then if you see if you move further, you want higher power and your time duration is, that means your charge and discharge rate is moderately okay. And in that case, if you see, all types of batteries come into the picture, and these batteries are not much different from the batteries what we talked in electric vehicle. What we have talked mostly there is about lithium ion batteries, but it could be anything else. The good part of this, these are all for stationary applications, so size and weight does not matter much. So what option we have? Advanced lead acid batteries up to 50 megawatt power, and for some minutes, 5, 10 minutes, 20 minutes, 30 minutes, maybe hour. Lithium ion batteries, it's for minutes to hours. In case supercapacitor also you can bring it down here. Advanced lead acid batteries, and then it's all comes metal batteries, metal air batteries, NAS batteries, zinc chloride, zinc bromium, vanadium, flow batteries. So these all are the regular users batteries. You can pull it out anywhere, and these are all are flow batteries. In flow batteries, we have also discussed, Professor Ashok has also discussed something like zinc air, aluminum air, and those batteries can also be utilized. Each one has its own advantages and disadvantages, and we'll go slowly through all those parts. What a energy storage technology should do? What are the services? The first one comes energy characteristic. That means storing cheap off-peak energy. When you have lot of energy and consumption is very low, at that time you store it and dispatch it during peak hours. What does it require? It requires large storage reservoir for large power capacity in gigawatt hour. Example, compressed air, pumped hydro, hydroelectric power plants, we are also thinking about the metal air batteries like zinc air, aluminum air. Second one is the load regulation. It's a very important part. Responding to small changes in the load, changes in the demand. Otherwise, what happens? Your frequency start changing and then grid trips, because grids works only between certain frequencies. It's suitable for load or frequency regulation because of very high response time. You need to immediately pump energy. Otherwise, what happens? If grid will trip, then everything else would be a problem. Our energy storage technology should be highly reliable. Continuous change in power output, that should be possible. It should also be suitable for frequent on-off conditions. Whenever I need, I can switch on. Whenever I don't need, I should be able to switch off. For example of that, for load regulation, flywheel, ultra capacitors, batteries. Not all the batteries, but yes, lot of batteries. Like lithium ion is one of the most suitable candidates for this one. Contingency reserves, whenever you don't have power, at that time it should be able to give you. Different types, spinning reserves like flywheel, it can give you power up to 10 minutes. Supplemental reserves, it works when now your spinning reserve is over. So gradually you are moving from 1 to 2. So that what you see, that the time stamp or time to react. The time to react for a spinning reserve is very high, means very small. The response time is very, very small. And now when it is responded, parallelly you start working on the reserve, supplementary reserve, so that it can be brought in. And then backup reserve, that when there is no power, it should still be able to serve you for longer duration. The next is load following. It's to fill the gap between demand and supply. Sometimes generation and demand. Capacity supply. If I have a sufficient storage, then I can always bring down the peaks, what I have talked in earlier slide, peaks to a level where it's average out. So even for future projection, if I have sufficient storage, I may not need to install a further plant of solar or wind or any other renewable sources. The reserve would still make it working for some more time in future. Transmission and distribution losses reduction. There's a lot of losses in transmission. If I have a localized storage, I can keep on pumping the energy there, and whenever it is required, I can take it out. Because every time you transmit the energy, there is always a I square loss, which you can reduce by providing the local storage. So with that, we will move to the what is the energy storage system.